I'm Anil Kumar. Thanks for watching my videos, writing comments and sharing your views. Here is part 2 on trigonometric identities. We have already discussed correlated identities and co-function identities with the help of example in part 1. Now we'll talk about compound angle identities in part 2. The example which I'm going to discuss, we have two here, will prove 1 minus sine 2x over cos 2x equals to cos 2x over 1 plus sine 2x. And the second one which we are going to take up is sine 4x over 1 minus cos 4x times 1 minus cos 2x over cos 2x equals to tan x. So these are two examples which we'll consider. But before getting into those details, let me remind you of the formulas. We know cos A plus B is equal to cos A cos B minus sine A sine B. Now this is extremely important. If I substitute B equals to A, then I get cos of A plus A, B as cos A minus sine A sine A. So that gives you one form of the formula, which is cos square A minus sine square A equals to cos of 2A. This is what we call double angle formula, right? So that is the double angle formula. The equivalent half angle formula is, let me make another box here for half angle formula. If I replace 2A by, let us say, theta, cos of theta. So I'm saying let 2A equals to theta, then A equals to theta by 2. Is it okay? So cos theta could be written as cos square theta by 2 minus sine square theta by 2. So it becomes half angle, but basically the same concept. Now, this particular formula is extremely important. We actually use it in many different forms. We could write it in three ways using the identity that cos square x plus sine square x equals to 1. And that really means that cos square x could be written as 1 minus sine square x, correct? So if I do that substitution here, I get cos 2a equals to, substituting cos square a with 1 minus sine square a minus, sine square a, and we have minus sine square a already there. We get the formula that cos 2a is equals to 1 minus 2 sine square a, right? 1 minus 2 sine square a. And similarly, if I replace sine square x is 1 minus cos square x. I'm using x, theta, a, all these different terms to get you familiar that argument could be written as any alphabet, okay? So if I do that, in that case I could write cos 2a equals to, I'm replacing sine square a this time with 1 minus cos square a. So I get cos square a minus 1 minus cos square a. That gives me 2 cos square a minus 1. Okay. So that actually, on rearranging, gives us different formulas relating angle with double angle and half angle, correct? So as you can see here, we do have two formulas here in addition to this, which is cos 2a equals to 1 minus 2 sine square a, and cos 2a equals to 2 cos square a minus 1, right? Now coming back to half angle formulas, that becomes the half angle. So you could rearrange it and write, if I rearrange, I could write this as 2 sine square a equals to 1 minus cos 2a, or I could write sine a equals to 1 minus cos 2a, Let me divide by 2 first. Square, square root, plus minus. Do you see that? Plus minus. So I could actually rewrite this in terms of half angle and write this as sine theta by 2 equals to plus minus square root of 1 minus cos theta over 2. Similarly, if I reorganize this equation, I get cos theta by 2 equals to plus minus square root of 1 plus cos theta over 2. So that's a quick reminder of all these relations. And now we will take up both these identities. Okay. First one here is 1 minus sine 2x over cos 2x equals to cos 2x over 1 plus sine 2x. Here I'll discuss an important strategy. Strategy is, on the right side we have 1 plus sine 2x. We want that. So if I begin with the left side, which is 1 minus sine 2x over cos 2x. If you carefully analyze, we want that in the denominator. So we say multiply by a term which is 1 plus sine 2x over 1 plus sine 2x. Now that is 1, correct? So if you multiply by 1, nothing changes. Nothing changes. It remains the same thing. So you can start with the left side, and the next step which we are going to do here is we'll multiply this by the term 1 plus sine 2x and divide by 1 plus sine 2x. Do you see that part? So we started with the left side, multiplied it with 1 plus sine 2x, also divided by 1 plus sine 2x. So what you get here is, in the numerator, it is difference of squares. Basically, you know what is a plus b times a minus b equals to a square minus b square, right? So what we get here is 1 minus sine square 2x. And in the denominator, we'll keep it as such. Will not expand. We have cos 2x times 1 plus sine 2x. Now what is 1 minus sine square x equals to? Well, 1 minus sine square x is cos square x, right? So we could write this as the numerator as cos square 2x. Do you see that? Divided by, we have cos 2x times 1 plus sine x. Right? Now, this cancels. One of these cancel. And what we get really is equal to cos 2x over 1 plus sine x. Is that clear? Which is the right side? So it's kind of very simple. A strategy helped us to solve this. My advice is not to expand 2x terms because you need them. And therefore we use this strategy. So I hope it's clear, right? Let's take up the next example where we'll actually apply the double angle formula. We need to prove sine 4x over 1 minus cos 4x times 1 minus cos 2x over cos 2x equals to tan x. I would like you to pause the video. You can recall the formulas, look at them, and then prove this identity. Now let us solve this. The question is, prove sine 4x over 1 minus cos 4x times 1 minus cos 2x over cos 2x equals to tan x. We'll use the formulas. Sine 2a equals to 2 sine a cos a. And cos 2a could be written as, there are three formulas here. We could write this as 2 cos square a minus 1. We could also write this as 1 minus 2 sine square a. Well, we could write this also as cos square a minus sine square a, correct? Let's see which one to use when. To solve the identity, rather prove the identity, we'll begin with the left side, which is sine 4x over 1 minus cos 4x times 1 minus cos 2x over cos 2x. Now if I say that a for me is equals to 2x, then 2a is 4x. Is it okay? So I can apply this formula here, writing the left side as equal to sine 4x could be written as twice sine 2x cos 2x. Clear? So that formula with a as 2x, 2a as 4x. Now 1 minus cos 4x. So 1 minus, so we have liberty to use cos 4x the way we want. Since there is one positive here, and there's a negative sign, I'll rather use 1 minus 2 sine square a formula. So in that case, what will happen is that one of these terms will get cancelled. So that encourages me to use 1 minus sine square a formula. Okay, so cos 4x, I'll write this as 1 minus 2 sine square 2x. You get an idea, right? So basically, I'm going to cancel 1 minus this term. So I get this 2 sine square a. The other thought could have been that I could have used 2 cos square a minus 1, cancelling out this numerator. Well, let's see. So what we get here is 2 sine 2x. Okay, let me complete this. 1 minus cos 2x over cos 2x. So we can simplify this term, cancelling these two for the time being. And what we get here is 2 times sine 2x over 1 minus 1 is 0. And we get 2 sine square 2x. And here we have 1 minus cos 2x. Okay, so 1 minus cos 2x. We want tan x as our result. So in this particular case, what we can do here is sine 2x, sine square 2x, one of them get cancelled, right? So we get sine 2x in the denominator. And 1 minus cos 2x, I can write this as, since we want sine on the top, I will use for 1 minus cos 2x the formula as, let me simplify this once more. So I'm cancelling sine 2x, I'm cancelling these 2's also. Is that clear to you? So with that, I'm left with 1 minus cos 2x in the numerator and sine 2x in the denominator. Is that clear? So let's work with this further. Now, since I need sine on the top, cos in the denominator, what I will do here is I will use sine 2x formula with 1 minus 2 sine square x. So I can write this as 1 minus 2 sine square x divided by sine 2x is 2 sine x cos x. Clear? So let's move on to this side. We can write our left side as equal to, if I open this bracket, 1 minus, let me write this like 1 minus 1 plus 2 sine square x divided by 2 sine x cos x. 1 minus 1 is 0, so we are left with 2 sine square x over 2 sine x cos x. So from here we could cancel sine x and the 2's. So we are left with sine x over cos x, which is indeed equals to tan x, or our right side. Right? So we have shown that left side is equals to right side. So you know we just got our result. You could have also replaced this by 2 cos square x minus 1 cancelled out these terms and got the result. That was also a very effective solution. So either way, you could solve this particular identity. I hope it helps you to recall your double angle formulas and use them in proving identity. Feel free to write your comments, share your views, and I hope that helps. Thanks for watching and all the best.